What are diastereomers? Diastereomers are such compounds that having the same molecular formula, same structural formula, same order of connectivity of atoms, and having same bond sequence, but they are different with respect to the three-dimensional orientation of atoms or bonds in space, and they are non-superimposable and non-mirror images of each other. They are called diastereomers, and they have different physical and chemical properties like melting point, boiling point, density, refractive index, etc. As they have different physical and chemical properties, hence we can say that they can be separated. They can be separated by fractional distillation, and crystallization techniques. So they can be separated by fractional distillation and crystallization because they have different physical and chemical properties, and they are non-superimposable and non-mirror images of each other. The diastereomers have two or more than two stereogenic centers. And these centers may be chiral or achiral centers. If these stereogenic centers are chiral centers, then these compounds show optical activity and rotate the plane polarized light in the clockwise direction or in the anti-clockwise direction. So we can say that not all the diastereomers possess optical activity. Only those diastereomers possess optical activity that have chiral centers. The carbon that is directly attached with 4 different groups is called chiral center. For example, we have a molecule like this. We can see that atoms of high purity lie on same side of the double bond. So it is our cis 2-butene, and in this molecule we can see that both high purity atoms lie on opposite side of the double bond. So it is our trans butene. So they are non-superimposable, non-mirror images of each other. So they are called diastereomers. We also say that cis trans isomers are non-superimposable, non-mirror images of each other, so they are diastereomers. For example, we have a cyclic molecule like this, and I place some mirror here. We can see that both OH are represented by the wedge bond, mean the both OH group are directed towards the observer and they are above the plane, so it is our cis form. And if one is represented by the wedge bond and the other is represented by the dash bond, then we can say that this OH is directed towards the observer and this is directed away from the observer, and this is above the plane, this is below the plane, so it is our trans isomers, and they are non-superimposable, non-mirror images of each other, so they are called diastereomers. In this molecule, we can see that this Cl is above the plane and this bromide is below the plane, so it is our trans isomer. And in this molecule, we can see that both Cl and bromide are below the plane or they are directed away from the observer, so it is our cis isomer, and they are non-superimposable, non-mirror images of each other, so they are called diastereomers. So this is all about the diastereomers.